So today we are welcoming architect Sheetal Rakheja, who is a graduate from Sushant School of Art and Architecture and an accredited lead green building professional, executive member of IGBC, president of International Fenestration Forum, and a visiting faculty at SPA Delhi. With her extensive work on the subject, we are honored to have architect Sheetal Rakheja today here with us to share her take on role of passive technology and nature in energy efficient and net zero buildings. So I'd like to welcome you, Sheetal ma'am, and yeah, you can.
Thank you so much. Thank you so much for the introductions. It's my pleasure to be here and share my thoughts, my views, and my experiences on designing the, green buildings today. So I'll just start. I'm basically an architect, an interior designer, ran a practice out of Delhi. So we've done projects all across India. Our focus is sustainability. Our focus is how we can, endeavor to balance environmental consciousness with the buildings that we design and make people who are going to inhabit, how their well-being, can be thought through. So we try to balance all of that. I'm also the chairperson of the Indian Green Building Council, Delhi chapter, and have been working a lot in promoting green buildings and kind of educating the students and people about what are the benefits of making buildings which are energy efficient, which are resource efficient, and which are concerning to the health and well-being of the occupants. So with that, I'd like to start my presentation. So I'll be covering today on the role of passive technology and the role of nature in designing energy efficient and net zero energy buildings. So, we've been working for last almost 25 years, and me and my team, we've been, it's been an amazing experience. When we started, we did couple of renovation projects where we did refurbishment of buildings and tried to make them more energy efficient. And then we did certain projects were totally greenfield, which were designed as green buildings. So along that, with every project, our intention or our, endeavor was to do better in terms of resource energy efficiency, so that, tomorrow our footprint is minimum. That was the intent. So the first understanding, was that at all scales, whether you are designing a small building to a large city, so at all scales, for anything to be sustainable, it has to integrate and balance ecology with social and economic components of that place, of that community. The second understanding is that there's a lot of heritage that we carry, and a lot of experiences from the past, a lot of learnings which we can take forward. So like, for example, these slides show that in a dry hot and dry place, how the shading of the streets actually help keeping the interiors and these streets cool, how having smaller windows help in getting less heat into the building, and how having thick thermal mass also reduces the heat inlet into the building. So there's a lot of learnings that we have from our past. The third understanding is that nature is a very powerful tool. It can help us, going forward. Nature is what can really transform something which is so simple and plain into poetic, something which is, everyday into sublime. It helps to uplift our spirits. It helps to regenerate one's body and soul. There have been enough researches which have been done, which show that how patients heal better, students perform better when they're connected to nature, when they're connected to green. We all love to take holidays around, nature areas, because that helps to really calm our minds, rejuvenate us, and make us, makes us much better to deal with day to day. So, and then there is so much biodiversity in nature. What nature builds is self-sustaining. So then there are natural systems which help to recharge the water, which, we have, our man unfortunately has taken a toll on them. That's why we see flooding happening, because these floodplains have been taken away. And these were like lovely areas, these wetlands, which actually promoted biodiversity and ecology. So, and of course, nature is very inspiring. Colors, textures. Unanimously, we all agree that there's a lot of beauty in that nature. That's why we gravitate towards it. So, the urban environment or even smaller projects that we design, if we can respect and engage nature and get it back, it will help to resolve, I think 80 to 90% of our problems. For example, these areas can not only be, ecologically more sustainable when you get nature, it is social, these can become lovely social spaces for us. And then, that actually gets a sense of belonging and pride for the community if these beautiful spaces are part of our daily lives. And they also, like I said, it helps to really rejuvenate us. So if they become part of our daily lives, it will make us see change. Then they can be all integrated together so that the environment, economy, and the social sustainability can all go hand in hand. This is a project I'd like to share, which we did back in 2008. It was one of the USGBC, one of the largest 10 largest projects, in core and shell category, awarded by USGBC. Now, this was earlier thought to be designed as one building, but what we told the developer was that instead of one building, it's much better to make different buildings which would help shade each other, so that the load from the envelope is really reduced. So what we did was that there are three buildings actually that you see here, and all these three buildings are mutually shading each other. They're all north south oriented. For a Delhi climate, orientation like north south works very well, because the sun travels from east to west via south. So north is, north generally you will have a very diffuse light, and you'll not have any direct glare coming in from there. And south can more easily be treated just by solar horizontal projections can help shade the building from the high sun. So you can still get a diffuse light without getting the glare inside. So these are from the second floor onwards, north south oriented. But what we did was additionally that we stilted the ground floor and created what we call as urban realm. We call a public realm where people can actually spend time, congregate, socialize. And these are the spaces where they actually connect with nature before they get into their building. So it's not that they're just getting off the car and going into their built environment. They're actually passing through these beautiful landscape areas. So even the entrance to these atriums are from inside. The red line actually, what we call as nature walk, is where people actually walk through, because the entrance to these atriums are from that side rather than giving it from the roadside. And then we placed water bodies along the wind direction, so that actually you would get a cooler wind when it blows through this stilted area, so that when people are actually spending time there, they are under a shade, they are getting a nice breeze. So that even when you go, in fact, when you go today there in peak of June, you go there in July, you go there in May, you will actually find people using these public areas, and that helps to form a lovely social community. So besides the work community, so they actually people socialize, they sit here, they play guitar. So it's a beautiful social space which has got formed, and of course while caring for the environment. Now so that's the view from the Sunken Court, overlooking these stilted areas and the buildings. That's the section which talks about the public realm, where we have the gym and the cafe and the lower ground area, which is surrounded by earth, so it's much cooler. There's a lot of light which does come into the sunken areas. So and there's a lot of visual connectivity in this campus. So it's a campus-like feel which gets formed, although these were core and shell buildings and there are different different tenants here. Yet, people mingle, and then, once they feel proud of this place, they take care of this space. If you see the section here, the office spaces are actually starting from the second floor onwards. And the footplate is such that it's able to capture natural light from both sides. So the reliability on the artificial light really goes down. Then over and above this, we took care that the window wall ratios were very balanced. They were, down to 25% instead of giving a complete glass building. And so it's only 25% of the windows which actually get in natural light. And natural light, I mean, almost 80 to 90% of these areas are well lit through diffuse natural light. Then you see the buildings and these windows also get shaded through these buildings which are shading each other. So that's an added advantage that we have here. This is what we call the nature's walk, from where people actually experience this greenery, chirping of birds, and there's water bodies. And this project got featured in National Geographic, where they actually, this is a project where almost 800 square feet area gets air conditioned by just 1 ton of air conditioning. Unlike your regular buildings, which about 200 to 250 square feet, you are using 1 ton of air conditioning. So, National Geographic came and they actually audited the entire building, and they realized that it was performing even better than what we were claiming. They interviewed people and they came to know that, people love coming here. In fact, they come to the office an hour or a half an hour early, spend time here before they go to the offices. And even in the evening, they would repeat this because, that helps to really, calm them down. It helps to really rejuvenate them every day. So that's what a lot of people gave a feedback. Now, to get to that 800 square feet for 1 ton of air conditioning, there's a lot of thought. There's a lot of integration of architecture and MEP and other services which took place. We had a lot of design charrettes because it was a tough exercise to actually adhere to the tight budget that you were given, at the same time achieve that very high energy efficiency. So besides the window wall ratio, the selection of the glass played a very important role. Since we had a low budget, we used a high performance glass on the south and west side, whereas the north and the east side, where the sun is, so north side because sun is not there, and east side it's only there for just a couple of hours in the morning when it's not too hot. So we went for a lesser performance glass to save on the costing. Now, the entire exercise was done by my team, where they ensured that the wastages are down to 1 to 2%. So the entire sizing of the glass, the light shelves, which help to penetrate the natural light inside, deeper inside the spaces, all those calculations were done to reduce the wastages. Then what we did was that even we have double insulated walls, but they are only on the south and west side. So we did a cost benefit analysis through computer simulations tools to understand, instead of doing a double wall all around, which would have costed us much more, it was perhaps, much economically and economically viable to do double wall only on the south and west side, and use that money to actually have solar panels or many other things. So that's how it helped us to really save in terms of the costing. Then this is the view of the Sunken Court, where people spend a lot of time. So the gym actually and the cafeteria overlooks the space. It's also a spillover of the cafe. These are the computer simulation tools which allowed us to establish the projections, whether it is going to be the south side, how much should be the projection to shade, whether it's going to be horizontal or a vertical projection. On the north side, what should be the projection? On the east side, what should be the projection? What should be the glass? And, so all those these simulation tools actually helped us to establish that. It also helped us to get the cost benefit analysis. It also helped us to actually predict on day one what would be the energy consumption of this building. So we use that and try to minimize the building energy consumption. Actually, these are some more views of the building. So in effect, we realized after doing a lot of to and fro, a lot of integration, we from the passive measures, I would say that how we oriented the building, how we shaded designed the building such that they would shade each other, how we took care of the window wall ratios, the selection of the glass, the insulation of the envelope, whether it was the roof, the shading systems. They actually helped us to save about 7 to 8% of energy, and then remaining energy came from efficient pumps, efficient chillers, heat recovery wheels, where we have pre-cooling of fresh air through heat recovery wheels. We pre-cool the fresh air which comes in, and then we also run air conditioner without using the chillers in the fair weather seasons, which are November, which are February, and March, where due to the heat of the people, heat of the equipments, you would still need air conditioning in a regular building. But here we are just pumping in fresh air during those months without using the chillers. Then, of course, using the right kind of lighting, having a natural light for most of the time by these shading systems, and then also having the perimeter lights linked to the daylight sensors. We were able to save almost 20% energy over the ASHRAE-based defined case, and 45% energy compared to a standard Indian building. Then we moved on to another project which was done later than Green Boulevard, which was Patni campus. It was IGBC first platinum project, and then this also was done. I mean, it actually saved us 35% energy over a ASHRAE base case and 50% compared to standard Indian building. Now, this was a campus across, the building. Now, here, interestingly, what we did was we realized that courtyard works very well, taking our inspiration from the past and how buildings were designed earlier in our composite climate. So this building is actually designed around 2 courtyards, taking care of the depth of the building, not to exceed a certain width, so that we are able to capture natural light from both sides and have a daylit building, not relying too much on the artificial light. Now, these are the 2 courtyards, and then we have through Venturi effect, wind which blows over the water body and through a jali cools this space completely, which is a landscape court where the spillover of the cafeteria is. Now, all these services, your HU rooms and all the service rooms were kept on the west side, leaving north and south side, with more glazing. Of course, we ensured that the window wall ratios were again between 28 to 30%. The performance glasses, we use high performance glasses. We then also introduced light shells. This section shows that, how light is entering through both sides. The expanse of the light was 15 feet, which was taken up to 18 feet by use of the light shells, which had a reflective material, which not only shaded the viewing glass below, but also helped to act like a light shelf. As I said that, we could enhance the entry of the light into deeper wood plates by doing that. So these are the 2 courtyards. The left one shows that, how wind can come through jali and over a water body, cooling the space completely. And then these are the computer simulation tools, which allowed us to, determine that what is going to be the shading system, what is the depth of the weighting system, something similar to what we had done for Green Boulevard. But here, because we were controlling the interiors also, there were these light shells, and then we had tapered ceilings on the side to allow deeper penetration of light. The corner, all lighting which was near the perimeter was linked to the daylight sensors and would normally not be on during the day. Then and then pre-cooling, free cooling, then modulating fresh air dampers linked to CO2 sensors. They actually help to get a very high energy efficient building. So from Green Boulevard to this Patni computers, where we were actually controlling the interiors, and we went even stronger in time. I mean, much efficient in terms of window wall ratios, shading. We were able to perform much better and give a better energy saving on this building. And of course, with the energy saving, there were many other factors which happened, where we were trying to connect people to nature. We were trying to do resource efficiency, ensure that glass wastages are, minimum. Selection of glass was done very thoughtfully. Then we moved on, this was 2014-15, where this was an existing building, a corporate office, where there was a lot of glass, almost 50 to 60% of the area was glass. But there was no natural light inside, and even if they, it was done in a way that they were put blinds, and they were not using it in a way that would have allowed natural light to be used. So there was a lot of reliability on the artificial light. There were not enough views, to this building. There was a garden which had lovely trees, but it was not used because it was a glass enclosed block, this building. I mean, there were no openings towards this garden, so it was not used. And then they also had an office area. If you see this left picture, the office areas were all at the ground level. So that's why it was all blocked, and there was no opening in this perimeter. So this garden was not really used. Then even the entrance of the reception was very narrow. There was an atrium which had a lot of potential in this building, but the way it was designed was that it was getting in too much heat, and all around it there were glass blocks or solid walls, so nobody could really enjoy this atrium as well. So we took up this challenge, and we said, let's retain the building, retain the core and shell, and make it as energy efficient and resource efficient as possible. Of course, we at the same time we wanted to create a very collaborative work environment where you had visibility, you had interconnectedness, as these were the inspiration from nature, where we wanted to connect people, we wanted to give them more flexible work environment, we wanted to get in a lot of natural light, we wanted to get in more greenery so that people would actually enjoy where they're working. So first and foremost, what we did was that from the roof and from the second floor where they had the cafeteria, we brought the cafeteria to the ground floor right side wing. And then we opened up these glasses to have openable doors. And then we, retained all the trees and vegetation that they had outside. They had a lovely garden. And we, of course, added a little more value to it. We had some decks so that they could be used for outdoor seating. We had a little bit of water body along this vein so that area would be cool. Then, of course, then we created a lot of collaborative spaces around this atrium. So this was the atrium actually, which was there, which had the potential, but was not really being used as the full potential. So all the collaborative spaces were around it. There's a lot of greenery added, so people could actually enjoy sitting there. So these are the floor plans. And if you notice that, so earlier they had a lot of HUs and other services on this east side. And this is where the view, there's a school here with a swimming pool and, a lot of nice greenery. So we opened up this area completely so that, people would get nice view. There were some services coming here, we removed. So this is actually the north side, which was opened up completely. We had more glass here, and the south side and the west side, we blocked more. And then all the collaborative zones came here. All the work areas were, on the right and the left wing. Now they were, the workstations were pushed away from the glazing because I'll just explain how we did that. So this were the computer simulation models, which actually showed that, if we go for, so we were debating what kind of projections to do. And then we went in for both horizontal and vertical projections, which, if we felt that if just, they won't look aesthetically so good if they were all horizontal and, crisscrossing. And then there were issues of pigeons also there. So what we did was we took the vertical projections outside the building, and the horizontal one was actually a light shell, and it came inside the building. And then then of course we worked on the cost aspect, so that so these projections are actually 450 deep. So we realized that if the projection is taken, I mean, if it is 750 deep, it would cut off the sun glare completely throughout the day, weather and in all seasons. But then it was costing a lot. So what we decided to do was that go for a 450, 500 projection, which was much easy to build, which was more cost effective. And then, the light, actually the sunlight was only there for an hour 45 minutes in the summers, and about 1.5 hours in the winters, which would come inside. So first and foremost, we actually moved away the workstations from that perimeter for the same. And then we went on for the cost effective option. But at the same time, then we said, okay, let's have the blinds pull down during those 1.5 hours. So we debated on going with daylight sensor control, linked blinds, which would just come down slowly for those 1 or 2 hours. So this is a typical section where, this is the project fin. The blue color is the fin, which projects out, and yellow color is a light shelf. which not only, penetrates helps to penetrate the light, natural light, much into the inside spaces, but also helps to shade from the sun for at least, in a half an hour or so. So these are the fins, vertical elements are the fins, which, beautifully, rhythmically go up and down to add a little character to the elevation, to the facade. This is the plan which shows how these workstations have been receded back. This is what the building now looks like, where the, glazing area from 50% has been brought down to, 30%. And west side is nicely shaded, heavily shaded. The south side is shaded. More glazing that you see here. This is the north side actually. The fins actually shade from the western sun. And here, all these doors that you see, this is a door actually which opens out to this outdoor spaces. So it's a spillover. People can actually enjoy, and they can, they can socialize here. And there are a lot of events and events which actually take place here. We retained all the trees, existing trees. This is view from the other angle, and you see the west side has more solid surfaces now. And so this is also the west side, heavily shaded. It had a lot of glass earlier, which is now removed, and we have more solid surfaces. Or even if you needed the glass, it is actually shaded by these by the jali, the metal jalis which are there. The right side image shows all the existing trees which we retained and we designed around it. This is the atrium which I showed you earlier, now nicely planted, and all the walls around it are broken so that, we have more circle, like the breakout spaces here, which so that people can enjoy this atrium. And you see the quality of the light. It's a very, it's a triple actually glazing on the top. It's a laminated glass, as well as, it's form of a DGU, which helps to insulate the heat which comes in. At the same time, it gets in the light. It's got fitting also, so that it's more of a diffuse light which you get in here. These are those breakout spaces which overlook that atrium. Again, just notice the quality of light. It's a very beautiful diffuse light which is coming in here. These are the workstation area. Those are the light shelves that you can see. And all along, these are all LED lights that we are using. Then there's another campus. We moved on to, this was a competition project where the building actually, the site sloped down to slope down here on the right side, where we showing the water body. There was a natural drain just across the site, and we filtered it, and we decided, the concept was that we filtered it and we use it for recreation purposes. So that's how the section shows that you have the building slopes. The entire site is sloping down towards this area, which is the water bodies. Now the wind directions here were, so these are the shading areas. So we ensured that, wherever people will use the spaces, they have to be nicely shaded. So all the recreation spaces were designed in areas which were shaded. The central atrium, or the central, the central atrium gets very nice breeze. And also we have east and west side. The wind is east, basically east-west, north-west to east. So what we did was we had these punches in the building to allow for this wind movement, and and then cooling the space. This is how the section looked like, and these are the breaks in the building to allow for that wind movement. So now here, since the the sun angles was much higher down south, so then we have actually had a jali metal screen which would shade the glazing. So that's how the building was designed to be, shaded, nicely shaded, glazings even on the north side, and then taking care of the wind. So all these projects, we were able to do buildings which were very high performance. But then to achieve net zero, which was what we actually were aiming to do as a vision or as a passion to see our country's development at zero energy, we realized that, so we took up a project where we said, okay, let's make it a zero energy building. This was way back again in 2008. Sometime, and then we said, we have to do a lot more work, where we have to reduce the energy consumption of that building to the bare minimum, so that the solar panels or the wind energy or any form of renewable energy that we provide, that needs to be minimum, so that because the cost of solar was high at that time, so and efficiencies were not that good. So we got down to that, and then we said, okay, let's design a zero energy building, which will be a building which produces as much energy as it will use over the course of the year. But for doing that, like I said, we had to reduce the energy consumption of this building to the bare minimum. For example, if a house consumes 6 to 8 watts per square feet, here we had to attempt to get it down to 1.5 or 1.3 watts per square feet, so that the renewables that we provide can easily be accommodated within the building, which is that you see it's right here on the rooftop. Otherwise, they would have taken the entire site, and obviously that would have costed much more. So we took these 4 old containers, which we designed around a courtyard. The east and the west side, we made them form verandas, which work very well in our climate. Then the south side had very small punchers, and the main glazing or the main source of light was the courtyard actually, and the north side. And then we put truss over it, and we insulated it well. I mean, this container actually carries almost 6 to 8 inches of insulation. So that's how it got formed. And then that's the main front desk and front deck. From where you enter, there's an entrance lobby, which of course is not air conditioned. And then beyond this point, the living, study, and bedroom is all air conditioned space. And 2 of these were containers actually form verandas for these glazings. So that's how the conceptual look and feel was. And then we went, I mean, this is just to explain the step-by-step approach, how we reduce the energy consumption, where initially the electrical loads for a regular bill, like if this was a regular house, it would of the same proportion as what we made Shunya. Then we replicated the model through energy simulation tools, and we saw that the electrical loads was 8,562. Cooling load at that time was 2 tons for this particular project, and carbon emissions were 7.6 tons. And then we oriented it right. So having a north-south orientation, as I explained, and we saw that we could save 2% energy. Then we insulated the roof, we could save another 2.5% energy. And then we insulated the walls. So like I said, there was almost 6 to 8 inches of insulation on different sides. And then this allowed us to a major reduction in major savings, which was 6.5% saving we could get. And then we saw that our cooling loads actually dropped down from 2 tons to almost 1.7 tons, and so did the electrical loads drop down. And then we used DGU and UPVC frame against aluminium frame, while we did debate about using aluminium frame with thermal break, but this was giving us slightly better performance at that time. So we went ahead and used UPVC, and then it helped to save another 4% energy. Then window wall ratios, we reduced the window wall ratios and got it down from 50% to 25%, as we were doing in other projects of ours, and it saved another 4.5% energy. We ensured that the windows placement was such, and the amount of glazing was such that it was able to get at least all areas to be naturally lit with diffuse light. So we don't really need artificial light except in the evenings. And then we had daylight sensors, occupancy sensors, which again saved 6% energy, shading devices, which saved another 5.5% energy. And then courtyard, of course, plays its role. The entire glazing, as I said, the major part of the glazing actually was inside the court. And we also had louvers to cut any glare which came into the courtyard. So you had a very beautiful diffused light which came into these spaces. And furthermore, since the first container was actually not air conditioned, and in addition, we had openable windows to these courtyards from all the areas. So it's because this courtyard was louvered, it was shaded, but still allowed evaporative cooling. It allowed heat to dissipate from inside. It became a nice source of ventilation. It became a nice source of light. And of course, it had beautiful plants inside. So it became a nice place for viewing as well. And courtyards, as I said, work very well in our climate. And this natural ventilation helped to save about 9% of energy, because many weathers or many, many times you don't really need air conditioning. But since you're in an enclosed space, you would switch it on because it would retain heat. So if you have openable windows, which will allow, in the evenings for the heat to dissipate, you can actually run without air conditions. Then we used energy efficient lights. We used, hybrid air conditioner, and that actually helped in cutting off all extra energy that this house required. Then, of course, efficient equipments, whether it was refrigerator and or washing machines. And, through both active measures as well as passive measures, we were able to, achieve that net zero status. It was just 3 kilowatt of solar PVs, which got installed on the roof, and roof had the area to actually take care of it. So we actually saved, if you see this table, from cooling load came down from 2 ton to 0.8 tons only, and carbon emissions halved. Our electrical loads, cut off by 60-65%. And that's how, and then we had solar lights, solar water heater, solar cooker. So it was no, so this was called Shunya, and Shunya means zero. But also interestingly, Shunya is also the shikhar of a temple, where we believe as humans, when we created those temples, is where the cosmos and the earth met. And that was the energy center. It was the energy center where heaven and earth met. And this is where everything gets created and destroyed. It was a closed loop cycle. So the same thing, the energy closed loop cycling created and finished here. Water closed loop cycling, not a drop of water goes out of this project. Closed in terms of wastage, everything is, converted to manure and used here. So this actually was true Shunya, zero water, zero waste, and zero energy. That's how it worked. This shows how the energy demand and the PV generation, how that cycle actually runs, so that in the end, the demand is actually net zero. This shows the food cycle, how it's created in the vegetable garden right here on this project, and use solar cooker to cook it. And all the food waste is actually converted to manure and used within the same garden. So again, even same terms of the water cycle. Then, vegetation on top actually help to insulate also. So using vegetation not only to grow your vegetables, but you're at the same time allowing it to insulate your roof. And then, of course, if you don't have enough roof area, you can use vertical green walls, vertical green gardens. So, and, coming back to nature, it's all about connecting ourselves to nature. These are some pictures that show how old materials were refurbished. There was no new, furniture or fixture, or no new furniture or doors which were really bought. Everything is old, refurbished, which is there. So, that these are some more pictures for the exhibition. So we took this concept. Now we've taken this concept to almost many type of buildings. We've done a project which is a club, which is a zero energy club. And then we've taken this concept to a office space, which we had designed, where this was a project, and it had a very tight boundary, which was 800 square meter. But we used, these were marshlands on the top where the irrigation canal is written, and there was an irrigation canal running through it. So we worked on the concept of borrowed landscape, where we didn't have solid boundary walls. We actually created a sense of a borrowed landscape, where these spaces, which is a marshland, actually looks as if it's part of the site. And then these are, we studied the climate of Kolkata, a warm, humid climate, and what, how the shading would work if we had, because it was a high FSI, so it would be a tall building, but how best to design it. These, we studied the wind directions and how best to use the outdoor areas. So this is the building where, on the north side, we put all the workstations, and all the cabins actually went on the south side, because north would give us, again, we realize a bigger expanse of glazing without too much heat or a direct sunlight, actually more of sunlight, not much of sunlight which would come in. So open workstations were kept that side, and the south side, which I'll just show you the picture, has the cabins. Now we did a lot of the models here, computer simulation models, to see what would be the best way to orient these solar panels so that they would be used to the optimum and they can be efficiently generate energy in electricity, but at the same time we get good views for the occupants and we get shading for these cabins. So we did a lot of permutation combinations, tilting these, solar panels, which you see cladding all across the south side, to various angles to see the best angle for view, the best angle for, electricity generation for solar panels, and the best angle for actually cutting off the glare. So yeah, and that's picture also shows this concept of borrowed landscape. It shows that how these umbrellas are made out of solar panels itself to actually not only shade but create lighting in the night. So coming back to this image, so we have some breakout terrace gardens here, and the top terrace garden is for the just above the corporate floor, and it is shaded nicely by the solar panels which come on the roof there. So this is a section which say that, okay, we have a public area here, and then private offices are from the second to the sixth floor. Seventh and eighth floor was senior management, and top was gardens, which were nicely shaded by the solar panels. So these were some concepts that we had done, how solar panels can be used effectively to shade also. So these are the glare and analysis which we did for the project, and understanding that how much heat and light is coming at various facades. So the intent, like I said, was that, how we reach the zero energy status for this building, which was almost 40,000 square feet. So we worked with the owner, who themselves were as part of the solar panel manufacturing, where we actually calculated the amount of energy this building would need, and then we calculated that, if you have to get to the net zero status, if we were to put solar panels all across the building on all facades, while ideally a south facade would be best for the generation of the solar, but at the same time, roof could be also used. So solar for the roof, solar for all the facades, we were able to get about 67.5 kilowatt hour generation. So now to get the net zero energy status, we had to reduce the demand of this building, energy consumption of this building, to similar or lesser, so that was the complete exercise, where we, again, like what we did for our Shunya project, through computer simulation tools, we modeled the building, and then we replicated the building, and we said on a computer tool, and then we said, okay, let's put wall insulation. We tried different thicknesses of wall insulation. We tried window wall ratios. We tried different type of glasses. We tried all active measures, that using high efficient chillers, high efficient VRVs. I mean, what would give us the best result? So after calculating all of that, we were calculating and brainstorming, we were actually able to arrive at the EPI of this project to 67.3 kilowatt hour per square meter, which was similar to what the solar panels with a combination of roof solar and the BIPVs, which is building integrated, solar panels, we were able to get. So we achieved the net zero status on design there. So in the end, I would like to say that whether it's a small building to a larger thing, if sustainability is the key to move forward in this world, and it's the demand today. So if we have greener street, efficient and cleaner transportation, we use renewable energy, we all will progress towards a goal of sustainable living. It's very much achievable, very much doable. It's not rocket science. So sustainable buildings and infrastructure will also help build sustainable communities by maintaining and enhancing quality of life, our interest, needs, and culture through integration of economic development, environment protection, and social health and well-being in mutual reinforcing manner. And, India will be a society with net zero energy bills, zero waste and zero water, and minimal carbon footprint, an earth-friendly society, positive India. Thank you.
Thank you so much, ma'am. That was very enlightening, and it was definitely something very insightful for everyone who's looking into sustainability and architecture. which I'm assuming a lot of people are nowadays. So, but my first question to you, I think you might even guess this, is why don't architects generally approach their projects through this angle of making it either net zero or extremely energy efficient? Why is that lacking in architects today everywhere? Like, is there any way of considering a project for this particular category of, or like putting it into a net zero category, or trying to make it more energy efficient? So how do people approach that?
So, Shivani, I think now since the awareness is more, I mean, there were definitely earlier also, there were architects who've been working consistently on this. Not to say that architects are not, but, sometimes the resistance comes from the clients because of two things. One is the mindset that it will cost more. And second is that, solar panels did cost a lot more, and things, and they were not as efficient. Now things have improved over, last couple of years. And having said that, many architects didn't have this, information or the knowledge base, because colleges also, I feel not every college was kind of pushing so much, but now things have really changed. There are people are aware, and slowly everybody is understanding the importance. We're seeing catastrophes happening everywhere, fires and flooding, and water shortages, electricity shortages. So I mean, it's the need of the hour, so people are being pushed. So now I see a lot more architects and a lot more people pushing that, right? Now, where the green buildings, if designed rightly, like I said, when you take care of orientation, when you take care of these small things, like I said, we've done very cost-effective buildings and made them platinum, really got them platinum. It's just a lot of integration, a lot of thought process, which needs to come in. And, so we have to get out of that lethargy more and push the clients, push everyone. It is possible with a minimum, I would say, like literally not much extra cost. But having, and earlier our codes also didn't talk about it. So there was like the leap from doing a building which was standard to a efficient building was a lot, because our codes never said. Now ECBC and all have come in. So automatically your buildings, if you design, you're quite a bit there without additional cost, right? Because you have to comply with the codes. So now not much investment is required. So things are changing. They have changed and they are changing rapidly. And we, us at IGBC, and I'm sure at other platforms, everyone's promoting green buildings. Now coming to the second thing on the net zero. So energy efficient buildings are not are no rocket science. They are doable. It's just a little bit of effort which is required and no extra cost. But yes, when you go to a net zero status, net zero energy, there the investment kind of comes in for putting the solar power, panels. Where I said, to achieve that also, because solar power was expensive, or doing renewable may be expensive, some of it. So what we did was, you reduce the energy consumption of your building to the bare minimum, and then you take that solar thing. But now there's so many incentives, there's so many companies coming forward, and they're saying that, okay, instead of paying your electricity bill, you pay us over. So, and then after some time, your building will get that solar power. So things are changing, and I think it's in the right direction, and it's not far that we see that, one day we will be a net zero, if not positive, at least net zero society.
Right, I'm sure that's something we are all looking forward to. So as an advice to a young architect who is probably taking up a net zero project, what do you think? Can you tell us if there is a checklist on how you can identify a project that you will be getting, or you are currently working on, that can become net zero?
Yeah, so as I said, we've done Shunya a long time back, and which is an example. And it was put up for an exhibition, and at that time, getting access to things was even more difficult. So, now there's so basically we put up for an exhibition. The response was great. There were students and people who came and saw that. Then we ran that house for almost 1 year. Developer ran that to see if it is actually functioning the way it's designed to function. And it did. So after that, we designed this office space, which is 40,000 square feet, and worked to make it a zero energy. We did a club which was zero energy. So there is examples are, and likewise, I'm sure there are other architects who've done similar kind of buildings. So now the examples are there. You know, there is I think there is one building in Delhi, which is a zero energy building. There's a building in Noida, which is zero energy. So there are examples of many for these young architects and students to go and see, and they're all available. They're all, those visits can be organized by these various, IGBC does all these, we at IGBC, and I'm sure other platforms also, people are organizing these visits. So it's all that is available to them, and computer generation tools obviously help to get that. I mean, did I answer your question correctly? I mean, is that what you wanted to understand?
Yeah, so I think we can get in more detail in the next question. I was going to ask you, we've seen in your projects that you've shown right now how you beautifully relate the outside spaces and inside spaces, like you did in the office space and the garden that was outside, or how you basically try to integrate a lot of things to bring out the sustainability and the design also. So can you talk about your design process? I'm not asking you to reveal your secrets, but just in a brief manner, if you can tell us about your design process when you're considering energy efficiency, right from the stage of conceptualization to actually the use of the building and the maintenance of the building.
Yeah, so I mean, right from the day one, when we get, we get a project, first is of course to visit the site to understand, what are the site parameters, what are the site constraints, where are the good views. Like I said, in one of the projects I was showing you that, they had beautiful swimming pool and garden on the east side, and they had put all the HUs. So the first and foremost, what we did when we had to refurbish the building was remove those to a south side where there was no view. So, that's what we do. We do visit site to understand, is there a shading? So let's say there's a tall building on your one side that may not even allow you to get too much light. There may be, so you have to understand, one is the site constraint. And then where are the trees? Are there existing trees? Are they very beautiful? We're doing a hotel where they had such a beautiful, the client was in a rush. Concept, though we did a concept, but then we said we need to visit the site. And when we visited the site, we realized that, where we were trying to do, we were trying to get a drop off, it had a very old, beautiful tree. So, so I mean, looking at that, we would want to retain that. That would become the main feature of ours. So, of course, you look at site, you look at the slopes, you look at so many things. In one project, we saw that there was a nala, irrigation canal. Can we use it to our advantage? So people will love being near water bodies, and it'll help to cool our play, cool our premises, and let's give some sit outs there so that you have a nice view there. So that's one. So one is studying the site. Then you spoke about energy efficiency. Yes, I mean, those are some checklists are that you take care of the site, you take care of this, what's there to view, you take care of any natural elements, how you preserve that, you take care of what are the wind directions, in that site. Because of course, like, for Delhi, let's say a wind direction is northwest, but that site may have its own microclimate because of a wind building or a tree which is, obstructing that wind. So you understand that. And then next step is that when you start designing, you take care north, where's the north, where's south. How would you design according to a climate? If you're designing in Delhi or versus you're designing in Kolkata, it would be different. So you take care of the climatology. You think of those as another big checklist. Then you, of course, understand what are, the client requirements. Let's say if you're designing a hotel, where will, you need a staff movement, you need a visitor movement, a guest movement, which will be separate. And then you understand from the site which would be the best areas to get that circulation, entries, exits, and then of course orientation. And once you've designed, taken care of your basic needs and utilities, and then you start putting in, okay, this is going to be my facade. But facade is it's not that I'm designing a facade separately. It has to integrate with what is inside, where I want good views, where I can get a courtyard to so if I have a restaurant, I would love beautiful views. I mean, that's a priority. If you have a room of a hotel, the priority is giving the best views there. So if you have an office, you'd again want to connect people to nature. so, and footprints don't be, do not be, so it goes hand in hand and all integrated, and how the MEP will function. It can't come in the end. It can't be planted in the end. It has to be from the day one itself. So that integration is important. And these are the checklists, mainly site and, functionality, and then nature, how we can get, integrated with nature. What are the natural elements of the site? So primarily, and then how you save, what kind of glass to choose.
That's right. So at every stage, basically, you have something that you
yes.
can consider. So coming to the facade, we saw some very interesting use of facade in your projects, like the way you've used light shells and films for the corporate office in Noida. So can you point us to one of the most interesting facades you've seen, sustainable facades you have seen anywhere in your career? And like how it worked, something that you really liked and have kept in mind, basically.
In terms of facades,
Sustainable facades, yes.
Yeah, so I think there's one in university in or institute in Rajasthan, which is very nicely used screens to, and then they have a corridor behind to shade the facade. While they are non-dynamic, but abroad I have seen, because we still have that constraint of cost. But abroad I have seen a lot of these, especially in Germany. I've seen facades which are, I don't recall the name of the buildings, but they have these dynamic facades and double facades, which would, change direction. The entire screen would shift and change direction to get in light when required, and not, kind of cut the glare when required. So every hour the screen would change its direction. I think that's truly, it's very nice, and it's in terms of energy efficiency, it plays a big role. And the facade would close, would open. So as sometimes you need the view, it opens up when you don't have glare coming in, and there are times when you need to shade. So those kind of facades, I think I really appreciate and like, and they are more in Germany. But here in India also, we have Jali is widely nicely, it's more static, but then again it's designed in a way that it's able to cut off glare most of the times. And lolly breaker buildings had that. They were very beautiful done, and even Louis Khan buildings have that. So those are the facades which you really appreciate.
Right, they're not very technologically advanced, but they are extremely effective.
I mean, it's not that they were technologically advanced, because they did the jali in a way that that would cut off glare. So they did all the calculations. Only thing is that they are not dynamic; they're static. That's the only thing. Now we have the technology to create dynamic facades, which will change. Which will unfortunately, the static facade, you cut off the view. From inside, the view does get cut with the jali. However, in a dynamic facade, how it helps is it cut off the view when it's glare, but other times it opens up completely. So they were also technologically, but yes, of course, now the way the technology is, it is really helping. It's a designer's dream now. You talk about it and the technology is there.
That's right. I was actually going to ask you this. If you can reveal to us what kind of softwares do you use for specifically net zero energy projects? Or if you can just tell us at what stages do you need these softwares? Like, where does the boundary come between old school creativity where you're actually conceptualizing, and then where do you take it on to a software and start analyzing?
So generally, once we are, we are through with the concept stage. We would, how we work. We want to do the concept, unless it's a completely contoured site where we start from day one. Where we have to model the site. But other than that, if it's a flat site, the concept we would normally do some sketches, and then we would shift immediately to the software, because to understand the sun angles, the shading and all. So it's right from the beginning only, that we are using these computer simulation softwares right from the very beginning. So then as we evolve, then of course, even in once the concept, we understand how the shading is happening, what is the depth of the glazing and all we would need. So just to get a ballpark idea, and then we freeze the concept. And those are done at a very boxy and, you know, conceptual level. The next stage schematic is definitely where we are trying to detail the building a little bit more. You know, what should be the height? What is the depth? Am I able to capture the light with this kind of, you know, so all through, I would say, we've been, you know, we are using it.
Right. And lastly, coming back to the question that we started with, what do you think is the role of passive technology and nature in energy efficient and net zero buildings? So how much of a role does it play, and how do you like integrate it?
I feel it has the most important role to play, both nature. I think it's, so nature, like I said, that, you know, when you connect people to nature, half your battle is won, because that you are finally designing for people, right? So if you can, so for their well-being and, you know, overall well-being, nature is very important. Just a beautiful tree outside can really uplift my mood. Just walking through a garden can uplift my mood. So as we saw in the projects, and actually not only us, when people, National Geographic came and other, you know, news channel came and they interviewed people, they said, you know, we love to come an hour early here. Some also, you know, made a little joke of it, saying that, you know, when we had fight at home with our wife, I come 1 hour early, I sit, I calm myself before I go to my work. Otherwise, I can't work. And then, you know, like Friday evenings, they say that there are people playing guitar here, and, you know, and birds are chirping, there's waterfall. It can't get better. They say that, you know, it's a lovely connect. So nature that way, yes, definitely. One is overall enhancement, overall well-being. It looks beautiful. That's one aspect of it. The second is that in our housing and other project, large campuses, we have really reduced the stormwater lines by 30 to 40%, using natural areas only for, you know, draining of that, you know, stormwater. Even along the roadside, we don't have any stormwater channels. This is just a, you know, a swale which is created, which will do. So you can actually reduce your, you know, all these stormwater lines. It helps to mitigate your heat effect. I mean, your urban island, you know, heat urban island effect. Just by having greenery, your temperature drop is, you know, 2 to 3 degrees. So of course it's very important. Like I said, half your battle is done. If you get in nature, you insulate your roof with terrace gardens you have. You don't need insulation as much. You know, the earth will do the trick. So yeah, so nature, of course, very important. Next, coming to passive. Again, the remaining half, I would say at least, half of the battle is again remaining half, or at least 40% of the remaining 40, out of 50%, 40% is one. Because if you orient your building right, if you do window wall ratios, if you do right selection of glass, I mean, all these shading of buildings, you've achieved so much of your heat, reduction just by doing all of this. And then remaining part, you're using active technologies like, of course, occupancy sensors and all that. Of course, they have a role to play, but major battle is done by these two aspects only.
Right. So I think both of these factors are the most important when it comes to considering a net zero energy. Sorry.
True.
Okay, so with that, I'd like to conclude this session. We thank you so much, Sheetal ma'am, for being here today. It was a very insightful and interesting session, and I'm sure it's going to inspire a lot of people to start designing more energy efficiently. So thank you.
Thank you, Shivani. Thank you, Thoughts team, for asking me to be here. It's been my pleasure, and I wish you the best. I mean, you're doing a great job of compiling these videos and putting it across to students and young professionals. I think it's a great job being done. So it was my pleasure to be here.
Thank you.